Hello guys and welcome back. Today we are continuing with our Mathsplorer series of questions. Guys, the question that you right now see on screen is a question from the Mathsplorer's paid papers. So if you want, you may try this question out, because this question is something that I would expect all of you to solve, because it's really relevant to what has come in JEE before. Okay, questions like these have been seen before, so I would expect that if you have learnt your 3D geometry well, then you might solve this question pretty easily. Okay, so without further ado guys, just give a try to this question yourself. I will wait for a few seconds and then start off solving this. Okay, so let's first give a reading to the question. So there is a line L1 which is given as you can see on the screen. I'm not reading it. Another line L2 is defined as the intersection of the planes P1 and P2. Okay, and if S denotes the locus of the points which are at fixed distance root 50 from the point 1, 1, 1, if P is the unique plane which contains L1 and is parallel to L2, then which of the following statements are correct? So options include, one is that we have to find the equation of the plane P, we have to find the shortest distance between L1 and L2. Okay, and another question is the bounded area of the shape formed by the intersection of plane P and the set of points S. Okay, we also have to find that. Yeah, that's the overall view, and option number D is actually regarding the centroid of locus of the centroid of a tetrahedron with vertices at the origin and the points A, B, C. So we will deal with that later. First of all, let's solve this. Okay, let's start off. Okay, so guys, first things first, I will write down the data. So L1 is given to be the following, that is x minus 1 by 1 is equal to your y minus 2 by minus 1 is equal to z minus 3 by 1. And the point on L1, if I take it to be say point number A, or okay, wait, actually, like point A is already used in option number D, right? So anyways, let's write this like this is in the form of your fractions, right? I forgot what is this called actually. There is some name behind this form. I'm sorry guys, I forgot. Like we will convert this into the single line vector form. The form of R vector is equal to A vector plus lambda B vector. So if we actually do that, then your R vector will come out to be as equal to, this is the equation for L1. This will come out to be equal to 1, 2, 3 plus of your lambda. Lambda is a constant, times of 1 minus 1 and 1. Right? Pretty obvious. And L2, it is given as the like line of intersection of the planes x plus y plus z equals to 1, and another one is your 2x, I'm sorry, not 2x, x minus 2y plus 3z is equal to 4. So if we need to find out the intersection, first is we need to find out the direction vector of L2. So direction vectors for these two planes are 1, 1, 1, and for this one is 1, minus 2, 3. So very obviously, I hope everyone will know this. If we take this to be say some n1 vector, this is the equation of, not, I'm sorry, not the vector, I should say this is the equation of the normal to the plane. So this is n1 and this is n2, the respective equations of the normals to the two planes. So actually direction vector of L2, direction vector of L2, if I take it to be say D2, then your D2, I'm sorry, this is D2. D2 vector will actually be N1 cross N2. So basically it will be IJK. Here this will be 1, 1, 1 and 1 minus 2, 3. Okay, so if you actually calculate this, I'm not going into the calculation, this will come out to be 5, minus 2 and minus 3. Okay. That's the like direction vector of L2 formed from the cross product of the two normals. Okay. So like let's keep it till this and proceed. Okay. So guys, right now actually we don't need to find out the complete equation for L2. Only finding out the direction vector will be very suitable. Okay. I will explain why. So guys, the first question, if we go into our option number A first, then option number A says that the equation of the plane P is something. So the equation of the plane P, so what is P? P is basically the plane that contains L1 and is parallel, I guess it was, yeah, it was parallel to L2. So if it contains L1, basically it will satisfy the point that is also on L1. So basically it will satisfy 1, 2, 3. It will satisfy this point, right? If we put in the equation of L1, if we put lambda is equal to 0, then 1, 2, 3 is a point that the plane P should satisfy. So that's not all. We also need to write, like, to write the equation of a plane, we need one point and the equation of the normal to the plane. So very easily, if P contains L1 and is parallel to L2, so the equation of the normal to such a plane would simply be d1 cross d2. Okay, so if we do the cross product, this will be your ijk and d1 cross d2. So 1 minus 1, and this will also be, I guess, 1 itself. I wrote it as plus 1. Like 1 plus 1 minus 1 and plus 1, and this will be 5 minus 2 and I guess minus 3. So this thing, if we calculate this, it comes out to be 583. Okay, I'm not doing the calculation part, guys. I hope you will do it. So now, because we have the normal and we have one point, very easily we can write down the equation. So this will be 5 times x minus 1. I hope you guys know very clearly how to write. And this will be plus of 8 times of y minus 2 plus of 3 times z minus 3 is equal to 0. So this will be 5x plus 8y plus 3z, and this will be 5 plus 16 is 21 plus 3 3 is 9, 30. So this is the equation of your plane P, and very obviously and correctly it was given in option number A, so option number A becomes correct. Okay, like you can see, right, these questions are very commonly asked in your JEE Advanced, and you should be able to solve this within, maybe within, even within the normal, not within the normal time frame, even within less than that. Okay, you should take less time to solve such questions if they come, because these are really common. Okay, anyways, let's move on to the next question. Okay, so I maybe said next question. It is not next question, it is next option. So option number B, it tells us the shortest distance between the lines L1 and L2 is 2 root 2. Okay. So like for that, actually the first thing that we need to do is we now actually need to find a point on the line L2. So basically for that, what I am going to do is I will write the plane equations, which are x plus y plus z is equal to 1. And this will be x minus 2y plus 3z is equal to 4. Okay. So guys, like if you actually solve this, this will be, I guess, pretty easy to solve. Like the first thing that you can do is directly put y equals to 0. Okay, you will get a point actually. So you may put y equals to 0 directly if you want. So that will make these two equations, x plus z is equal to 1 and x plus 3z is equal to 4. Now this is a like two variable simultaneous equation. So if you solve this, this will come out to be equal to z equals to 3 by 2 and x is equal to minus half. Okay, easy calculation, you can do it. So actually this point that we want to find would come out to be minus half, 0 and 3 by 2. Okay. Okay, so I hope you guys know that your r vector is equal to a vector plus lambda b vector. Or wait, I will write down the two equations only. Your line L1, if I take it to be r1 vector, your line L1 or r1 vector, whatever you say it will actually come out to be this. I'm writing it. Okay, so guys, these are the equations for your L1 and L2. I have depicted them as R1 and R2. So the distance, I hope you know this formula. I will still write it down. Because these two lines are in parallel, right? So the distance has to be found using this formula, that is A2 vector minus A1 vector. and this will be dot with d1 vector cross d2 vector. I hope you know what a1, a2, d1, d2 are. This is a1, this is d1, this is a2, this is d2. Okay, and this thing is divided by your modulus of mod d1 cross d2. Or I'm sorry, not modulus of mod, I should say mod d1 cross d2 whole modulus. Yeah, that is more appropriate. So guys, I am not calculating this. I will tell you the values anyways. This mod d1 cross d2 thing would come out to be equal to, I guess, 7 root 2. Okay, and this numerator would come out to be 28, this complete numerator. So actually this would come out to be 28 by 7 root 2. So this is 7 fours are 28, 2 into 2 and root 2. So this would be 2 root 2. Okay. So guys, I think option number B is also correct. So your option number B is also correct. Okay. So moving on to option number C. Okay. So before starting off option number C, let's analyze something that is told in the question. So basically the question said S is the locus of points. Okay. Locus of points which are at a fixed distance, and that is root 50 something units from the point 1 comma 1. So guys, I hope I don't have to explain further, because in 2D we know that this is a circle, but here in 3D the locus will be nothing but a sphere. Okay, it's a sphere like this. Obviously if I even draw, then it will be very difficult to depict, but it is a sphere like this in 3D, and this is the point 1 comma 1 comma 1, and all the points on the, like, this is the locus S, so all the points will be at fixed distance of root 50 from 1 comma 1 comma 1, right? So S is a sphere of radius root 50, and this is centered at C1 comma 1 comma 1. So if we want to find out the distance of this point C from the plane P, and what was our plane P? Plane P was 5x plus 8y plus 3z is equal to 30. So if we want to find out the distance of this point from the plane P, then, and depict that maybe as small d, then your small d will become 5 into 1 plus 8 into 1, and this will be 3 into 1 minus 30. And this thing obviously is whole divided by your root under 5 square plus 8 square plus 3 square. So if you evaluate this, I hope you know this formula guys, right? So if you evaluate this, this will actually come out to be 14 by 7 root 2. So basically this will be root 2. Okay. So now, like our question said, the bounded area of the shape formed by the intersection of plane P and the sphere. Plane P and the sphere. So they are trying to say that this will be something like 48 pi. So let's find that out. Okay. So guys, right now I am going to give you a little bit of visualization, and that is, if I draw a circle here, and please consider for the time being that this is not a circle, this is a sphere. Okay, for the time being, just consider that this is a sphere. So if this is a sphere and a plane, that is your plane P, it goes and cuts the sphere like this. I know it's very difficult to depict here, but anyways, try to understand. So actually, if a plane cuts a sphere like this, then say if I take this top cross section, maybe the cross section will be something like this. Okay, like, just consider that, what do I say? Say you have a big watermelon, okay? You have a watermelon and you are taking a huge rectangular knife and cutting it into like equal or unequal halves, whatever. So if you take these two halves, like this particular half above and this particular half below, and say if I take this half above and try to observe its cross section, then the cross section will appear something like this, right? Same for the lower part also, it will appear something like this. So if that is the case actually, then this cross section is actually a circle, right? So basically what this means is if this thing is your, say, radius rho of the circle, and obviously this is maybe the center of the circle, right? So I can consider that this will be r. So typically, like, we need to find out the area of the point of intersection of plane P with the set S, right? So if we actually, like, see, we need to find out whether it passes through the center also or not, because that is important. Okay, so we need to test that. Wait. Okay, actually I said something wrong. We don't need to test whether it is passing through 1 comma 1. Okay, it's like we don't need to test at all. Just see what I'm doing. Basically, if you observe, I have drawn a right angle triangle here, and right now what is going to happen is that your this distance will be d. Okay, this, I'm sorry, not this, this distance will be d, this distance will be small r, the radius of the sphere, and this distance will be something of rho, which is the radius of the circle, this cross sectional circle. Okay, so actually these will all come in a right angle triangle. I have not drawn it. If you want, you can try to imagine and draw a little bit of diagrams. You will automatically understand. Okay, this will be the exact arrangement. So if you actually want to find, like, if you find out rho, then the area of the circle will automatically come, right? Because rho is the radius of that circle. So basically rho will be from Pythagoras theorem, r square minus d square. So it comes out to be root 48. So area of your circle will become pi rho square, or rather 48 pi, which means option number C was also correct. Okay, so this is gradually going towards an all correct, but anyways, we need to still check on option number D. So let's move on. Okay, so reading on option number D, it says that a variable plane parallel to the plane P. So a variable plane parallel to the plane P would be 5x plus 8y plus of 3z is equal to some constant k. Okay, and it says that it intersects the coordinate axis at points A, B, and C. So if we try to find out the points A, B, and C, then A will, like, we have to put, for x we have to put the other two 0, for y the other two 0, and so on. So you will get this as k by 5 0 0. B, you will get it as 0 k by 8 0. C, you will get it as 0 0 k by 3. Okay, these are the 3 points. So the locus of the centroid of the tetrahedron with vertices at the origin and the points A, B, and C. So if we want to find out the centroid of the tetrahedron, so basically centroid of a tetrahedron, actually this is not very much in your syllabus, little bit outside, but like, even from your sense you can say that centroid of a tetrahedron with origin and at these points would be the sum of all these. O is the origin. Okay, this is not 0. This is O. O plus A plus B plus C whole divided by 3. So if you see, like, if we manipulate this, this will come out to be k by 20 and k by 32 and k by 12. So very surprisingly, like, if we equate all of these, 20x is equal to 32y is equal to 12z is equal to k. So if we do, like, constant doesn't anyways matter. So if we, I guess, cancel this with 4. So 5x is equal to 4 8s are 32y is equal to 4 3s are 12z. So 5x is equal to 8y is equal to 3z. But it becomes wrong because it is given 5x equals to 9y is equals to 3z. So this thing becomes wrong. That means option number D is wrong. Okay. So guys, sum is done. Our correct options for this question will be A, B, and C. Okay, so I hope this question was clear and really unique question, like a lot of imagination needed, especially for that circle part, how the plane cuts the sphere. These things are to be imagined by you. Okay, you have to imagine these in your mind. You will not always get the provision and even the time for drawing things. So guys, I hope you have liked the question, and this will be the end for today's video. If you have liked my channel, do like, share, and subscribe. Any doubts, always come in the comment section, and also do join my Telegram discussion chat for fruitful discussions, questions, and etc. And that's it for today, guys. Let's end this video here. Thanks for watching.